Building a self-sustaining colony on the moon hinges on the development and implementation of sustainable technologies. These innovations are essential for ensuring that human life can thrive in the harsh lunar environment while minimizing reliance on Earth. One of the most critical sustainable technologies for lunar living is water extraction and recycling. The moon's poles contain water ice, which can be mined and processed to provide drinking water and oxygen. Advanced extraction techniques, such as heating the regolith to release water vapor, can efficiently harvest this vital resource. Additionally, closed-loop water recycling systems will purify wastewater, ensuring a continuous supply of clean water for colonists. Energy generation is another key area where sustainable technologies will play a vital role. The moon receives abundant sunlight, making solar power an ideal energy source. Solar panels can be deployed across the lunar surface to harness this energy, providing electricity for habitats, life support systems, and machinery. Innovations in energy storage, such as advanced batteries or thermal energy storage, will ensure that power remains available during the long lunar nights. Food production on the moon presents unique challenges, but sustainable agricultural technologies offer promising solutions. Hydroponics and aeroponics can be utilized to grow crops without soil, using nutrient-rich water solutions instead. By employing lunar regolith as a growing medium, colonists can cultivate fresh vegetables and fruits, providing essential nutrition while minimizing resource use. Vertical farming techniques can further optimize space and resource efficiency, allowing for higher yields in smaller areas. Waste management is another critical aspect of sustainability in a lunar colony. Advanced recycling technologies can convert organic waste into compost for agricultural use, while other waste materials can be repurposed for construction or manufacturing. Implementing a circular economy approach will minimize waste and maximize resource utilization, ensuring that the colony remains sustainable over the long term. Life support systems are essential for maintaining a habitable environment. Sustainable technologies that recycle air and manage carbon dioxide levels will be crucial. Systems that use plants to convert carbon dioxide into oxygen can create a breathable atmosphere while also providing food. Innovations in bio-regenerative life support systems will enhance the colony's ability to sustain human life without constant resupply from Earth. Transportation within the lunar colony will also benefit from sustainable technologies. Electric rovers and vehicles powered by solar energy can facilitate the movement of people and goods across the lunar surface. These vehicles will be designed for efficiency and durability, ensuring that they can navigate the rugged terrain while minimizing environmental impact. Communication technologies will play a vital role in connecting the lunar colony with Earth. Sustainable satellite systems can provide reliable communication links, enabling colonists to stay in touch with mission control and access vital information. This connectivity will be essential for coordinating operations and ensuring the safety of the inhabitants. Safety technologies are paramount in a lunar environment. Radiation shielding is critical to protect colonists from harmful cosmic rays and solar radiation. Innovations in habitat design, such as using regolith for shielding or constructing underground living spaces, will enhance safety while promoting sustainability. Additionally, emergency response systems must be developed to address potential hazards and ensure the well-being of the colony's inhabitants. Cultural sustainability is also important for the long-term success of a lunar colony. Technologies that promote social interaction and community engagement will help maintain morale and foster a sense of belonging. Virtual reality and augmented reality platforms can provide recreational opportunities and facilitate connections with Earth, enriching the cultural life of the colony. In conclusion, sustainable technologies are the backbone of a self-sustaining lunar colony. From water extraction and energy generation to food production and waste management, these innovations will enable humanity to thrive on the moon. By focusing on sustainability, the colony can minimize its environmental impact and create a model for future space exploration. As research and development continue, the possibilities for sustainable lunar living expand. The moon could become a testing ground for technologies that may one day be applied to Mars and beyond. The journey toward establishing a self-sustaining colony on the moon is not just about survival. it's about creating a sustainable future for humanity in space.